Audio test 1, 2. All right. We'll just grab directly from my mic. I'll just stick the mic in my face. All right, let's see here. Arduino. Don't think I actually have it installed. Just download. Please accept our cookies. Now I gotta add the desktop audio. Let's see here. All right, I think that is my desktop audio. Let's find out. Let's generate some audio. Well, hello, Malkaz. How's it going tonight, sir? Thank you for the resub. Not playing any video games tonight?
Hi.
I am programming some. So last week, I was reverse engineering this display, and this week I am going to try to use this guy to drive it. So hook it together and see what happens. So either I'll get somewhere tonight or I won't. Good old butt spot. So would you saw you stream it? Were you streaming earlier? What were you streaming? I was at my Monday walk, so I'm not home on Monday nights. All right, sketch. So we're going to use this fancy program here to write some software. All right. Tools, board, Arduino Mega. Do something. Here. Make it work. Is that how it works? That's how I write some code? Nope. That is not how it works. Alright. Got myself some coffee. But first I'm going to cheat. I'm going to open up an existing project that I already have in my Google Drive. Arduino Stern White Star. Open this guy up real quick. And, well, I told to open it. Oh, there it is. Alright. We're going to take this code here. And I think I'm going to use the same pins. So we'll go over to here and we will open up a Arduino Mega pinout. This is the board we're going to be using. Hey, we got new plans for you. Yeah, go away. All right. How about just the pinout? Pinout, please. Come on. Where is the pinout at? Connect to your board. Make the light blink. All right, let's go with this picture. There we go. So, this is our pinout of the board. Let's just save this image on the desktop here. Desktop, save. And then we'll just preview that so everyone can see it. Open. Just go ahead and drag it up here in the corner. So that'll be the board we're working with. Don't need this open anymore. I don't need that. So this is just some quick reference stuff. I'm going to do some data logging. Let's get that set up here. Turn on the serial port. We're going to set up, we're going to use all the same I/O pins down here. All these same pins, just like I was using in this one. Set them all as outputs. Except for this one to output, 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 output. Alright, all outputs. Sorry if my keyboard is loud and clicky. Also, if my audio sucks, please say so. Maybe I'll talk deeper into the microphone. So I'm just going through here and setting up my output pins. So I'm going to need, where's my notes from last week?
Hi.
Hello, Don. How's it going this evening, sir? Hope you're having a well and pleasant evening. Hope you had a wonderful weekend. And where did Bill do his notes? I wrote all this stuff down last week. All right, I think I found my chicken scratch. Found my chicken scratch. Chicken scratch. This is from last week's video. So Here's the screen. Alright, so we have ground and 5 volts down here. This pin is ground on here. So then the next one next to it's 5. So we can actually use the 5 volts off this drive, the Arduino. But we do need to keep the ground reference. So the good thing is there's a ground pin right here. On these two pins are ground. Unfortunately, that means we can't use a ribbon cable because the display, the output enable is the lower pin. So we're gonna have to use little jumper wires like these. Some of these here, which means I'm gonna have to go find some because this isn't gonna be enough. So I must hunt some of these down. I guess that's what happens when you're not scripting. Audio is very low. How is that? Is that any better? I don't know if it is or not. How is that? Is that any better? Oh, I can hear myself. What's going on here? Oh, yeah. Let's see here. Properties. Done. Oh. No, it's turned all the way up. Yeah, I was using something else here. Hold on. Let me see if I can get this stupid thing to work. For some reason, this was broke, and I decided not to use it. And obviously, it is not going to work. So I'm going to have to go in here and fix this. All right. Here's my audio. I'm coming in. I'm going out. Going out on the master. And all right. Whoa. All right. Audio? Okay. That's that. Now, I go over here, hit this button, and nope, double click on this, and go to that. Hello? Does that work? How does that sound? Hello? Is that any better? How's that sound? Yes? No? Maybe so? Magical. Is that no bueno or yay? I I'm not worried about background in a second. Do you hear me? Okay. It's supposed to take the background noise out. You're not supposed to hear the crap in the background. That's the goal of this. Goal is to amplify my voice and remove all the crappy audio in the background. So hopefully that is working. Apparently my Audigy software decided to output the audio to a totally different port. So now I need to figure out what's going on over here because it's almost like it's got a cat filter on the. Nope, there's no gain. Mixer. This is this microphone. Hmm. Discord or my stream Open Labs is saying it's capped. Not sure why. But it's not showing capped on that. Let's see if that does anything. No, maybe. Okay, that goes up a little more. All right. I don't know how that sounds. If that's too loud or sounds like crap, please let me know. I do not have any music playing. So if you're looking for music, please say so and I can turn the music on. All right. No music. All right. Back to what I was doing. Malkaz obviously didn't say that my audio was down. Thank you, sir, for telling me my audio was down. Maybe I should get myself a muted icon here. This is the proper icon to be used right here. Muted. All right. So what I'm doing is I'm going to take this display and I'm going to drive it from the Arduino. So last week we reverse engineered this display, figuring out what pins do what. And then we use the pattern generator to try to drive it. We failed because the pattern generator is way too fast. But we did confirm it was working. So what I need to do is figure out, I need 2, 4, 6, I need 8 pins for a row. So I'm going to do is do column 0, column 1, column 2, column 3, column 4, column 5, column 6, column 7. All right. Those are my columns. And then go 36 through. Oh, that's cute. Thank you for not making this so simple. All right. So it goes 36, 37. So I want to try to keep this as simple as possible. So 51 and 53. These are my output enable 0, 7 and output enable 0 through 7, 0, 8 through 15. So when these, so the path was data, latch enable, output enable. There was no latch enable. Or was there? So the data columns on this, these guys here, when low, enable column. That should be 36. So I'm going to do this. It's 36, 38. $36, $38. Put all the evens on one side. It goes 36, 38, 40, 42, 44. So all the evens are on one side, all the odds on the other. So first thing is we got to do is set up all our pin modes. So we need a 44 and 46 and 48. Put those in there. We don't need that one. One, two, three. Column 4. Column 5. Column 6. Column 3. Column 2. Column 1. Column 0. And then now on the other side, starting with 37, 39, 41, 43, 45, 47, 49. This would be row 0/8, row 1/9. And the reason why it's 2 rows is because the display has 2 latches for each row, or for the high low or the low row. And everything's 0 bounds because we're nerdy like that. So 50 and 52, I am not going to use, so we're going to set those as inputs. This way, if we short at the ground or short at the hot, it won't damage anything. And 51 and 53 are outputs. And then now we want to write, so we can write some information on the output. Debug information. All right. So we're going to do something super simple. We're going to write create a function, void right column, and let's call that I, and then we're going to go copy this whole function, which is probably something well easier to do this. But basically what we'll do is we will check data, we will AND it, and then output it. And then we just go down the line. So, but we need to fix this. So this is, first one's going to be 36. We move everything around. So it's 38. Not address. Six. 4. Damn it. 36, 38, 40, 40, 40, 42, 42, 44, 44, 46, 46, 48, 48, 50, right? Now, where'd I goof up? Oh, I missed the whole entire freaking column. Column set. Which means I get the same thing here. All right. So when low, this will turn that column on. Right? Low or was it high? I believe it's high. When high, it enables the column. All right. This gives me so that'll be right column. We're going to take this whole function and we're going to do a right low or right row. Right row. This time we're going to do starting at 37. So 37, 37, 39, 39, 41, 41, 43, 43, 45, 45, 47, 47, 49, 49, 51, 51. So what we're going to do is right row 0 And then we're going to digital write. And we're just going to pull 52 and 53. 52 high. 53 high. And then we can pull them low. I really don't like the fact that these are all individually written pins. I'd like to be able to just write the whole port in one fell swoop. So long as we don't do this with this high, then we're fine. Then we're going to go a digital. Then we're going to do a right column 1. And then we're going to do a delay 10. And then we'll do column 2. Delay of 10. We're going to do delay of 2. Let's do 2 seconds. And I should probably spell this right. We just do this for let's open my other one. We know I want the soundboard. This one maybe? No, that's my joystick. Wait, this one. Oh, I just did a loop. No. Oh, Google Drive. Oh. Seriously? D. Google Drive. Arduino. LED sign module. Ah, there. All right. All right. So what we're going to do is leave that one. And then we're going to do column equals column plus 1. If column is greater than 8, column equals 0. 1. So that should increment. All right. We compile. We'll compile. Word. Plugging the port in. And then uploading. Done uploading. All right. All right, there we go. What I do want to do is try turning on this other microphone. I don't know how well this is going to sound over here, but we'll give it a shot. Black. So 2, 4, 2, 4. Right, that'll be data. 2, 4, 2, 4. That'll be data. These 3 will be ground wire. Power. Positive. All right. Let's see if we can hook these all up in one row. It's totally fine. 1, 2, 3, 4, 6, 7, 8. This is the columns. These go all on top. 1, 2, 3, 4, 5, 6, 7, 8. Hey, look, it's counting in binary. Not what I wanted to do, but at least I know it's working. So I will need to adjust the code. What did I do here? All right, I got these all. I got. Oh wait, that's right. That's 5 volts. So. high order. Down. Here. 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 All right. Let's go back to desktop view here. All right, so we need to fix the code. 255 turns everything on. Columns. Need to go like this. 0B 0 0 0 0 0 0 0 1. Zero. 1 0. 1 0 0. I'm gonna make this D a variable. I'll make it 1000. Switch to workbench overhead view. All right. All right, let's try a 500 millisecond delay between them. Let's do 100. It's a Cylon.
Hi.
Hello, sir. How are you? What's up, Jack? Oh, Jack. What are you doing, Jack? I think you left. Loser. All right. So what I need to do now is so a row can be 2 digits. Okay, man. Sounds great. A lot of people go to bed dreaming of me. You can just be another one. Another one of the many. People like dreaming of me. It's like dreaming of Jeannie. All right. Row L equals row L. Row high equals row high. Actually, if row L is over 255, row high equals row high plus 1. If row high is greater than 255, row high equals 0. Row low equals row low. Row low equals 1. So we're going to then write row low. And we're going to write row high, just 53. Take that out. Row low and row high. All right, upload. Upload. Oh, whatever. I don't need this in the setup anyways. Why am I doing that? All right. All right. Let's change the speed. May just go faster. Let's make this go a lot faster. Let's go. 10. All right. I clearly have the rows upside down. All right. Well, we got it where we can. So now I need to work on a font table. I don't think I have GIMP. I do have GIMP. No, I don't have GIMP. Do I not have GIMP? Nope. Gotta install GIMP. So if we do a note, so if we do a file and we do fonts like this, 4 digits? No, 2 digits. F FF is 16 bits. So it'd be FF like this. 0x. Hmm. All right. Let's see. How do you do this? Arduino font. There used to be a way to do this in GIMP. Or was it Inkscape? All right, let's watch this YouTube video. All right. How do you make the font, dude? You're not showing us how to make the video font. Not helpful.
Basic LED matrix on your computer can light of the and why this into the switch LED line. This is the code. You should find the pins high to be assigned rounded.
Not helpful. Let's translate pin do. No, this must be a custom function. Yeah. So using a translate pin function. All right, let's do this. We're going to do byte col pins. This is 8. So 36, 38, 40, 42, 44, 46, and 48. This is supposed to be an array. Byte row pins. Seven, 39, 41, 43, 45, 47, 49. Take this crap out. We don't need that crap. Now what we can do is course, it's compiling error, and it doesn't say anything. These should be commas. I got my C code wrong. Yeah. Hmm. What? No. Turning them all on. But I also need to turn it off. This should start at 0. Now what we're going to do is byte. We go into Excel. And all right. Now we need to convert this to hexadecimal. So this is the weight 1, 2, 4, 8, 16, 2. Actually, no, we just need to do like this. It's going to be binary. FC. So 252, 252. The next one's 25. So clear this. 1111 111 0. 254. then it's going to be 7, then 2. No. Headache. I need to figure out how to generate fonts. Arduino font. All right. So we're going to do God damn it. What the hell? Hey, changing this code.
Hi.
Hello. Hello, Alex. You're late, man. I'm about done. You're late, brother. Yeah? Well, I'm about ready to see if I can get this thing to blow up here. Yeah, it's the same one from last week. I am now switched to Arduino. Problem is I'm trying to generate a font, and all the font generators are designed to go, the columns are designed to go the other way. So you have to visualize the font on its side because it gives the font is along. So this is the actual row, but this needs to generate the font going in a column this way. So I need a two 8-bit digits numbers for each one of these. So I wrote a function. We generated this, which then I can just simply call the pin number based on the value and turn it on high and low. But now I realize that if I need to turn on more than one bit, I need to check every bit and then update all the bits to be on the latch it. So right here I'm latching. So right now I'm just checking this. I'm so tired as hell. I'm taking 0 through 8. I'm just incrementing this number, as you can tell when I go to the. So here I have counting 0 through 8, and then when I hit 8, I reset back and I go here. So I set it high, I latch it, I set this high, and then I latch it. It should. Yeah, that's what I should see, just like that. Actually, no, I need to set it low. So this is turning the pin high. And then I need to turn the previous pins. Turn them back off. Yeah, it's not so much right versus left. It's more of left versus right, or X versus Y. Oh, this latches the whole column, and most LED matrix fonts latch the row. I have no idea what I'm writing here. Right now, it's just looping through. There shouldn't be no more than 2 bits on at a time. I don't know what's going on here. Rolo. So what I want to do is no, I haven't gotten that far, dude. I haven't. I'm trying to first build a library to draw, and then after I draw, then I can go to the next. Hi, Brian. How are you, sir? But first, I'm trying to draw the font. Get the font sorted out and draw. I got the columns sorted, but now I need to convert 2 8-bit values for each row, for each column. The rows are sorted. The columns is what I need to figure out. So there's a column low and there's a row high and a low low. So there's an 8-bit value that signifies the first 8 bits, and then there's 8 bits for the bottom. So thanks for the follow, Brian. How are you doing, sir? Or do you just be called Proc?
Hi.
So for instance, we'll just do this. I'll just delete this. This is not working, so we'll just do this. So if row low equals, so if we do 255, or if I do 0 and row high equals 0, if I do that, it's just going to turn on those 2 bits. If I do 1 and 1, it'll now do the next 2 bits. If I do 7 and 7, it'll do those 2 bits. If I do 7 and 0, so there's my first problem. I'm using an array that I cannot not turn a row off. So I need like a -1. So what I need to do is, this is a 0 bound array. 0, 1, 2, 3, 4, 5, 6, 7. So if I have a value of, say, 8, I don't want to do anything. So if row low equals 8, but that's not what I need to do. I need to take and turn all the bits. I need to go through each bit and mask it. So I need to do what I did over here with, I need to AND it. I need to do I do row low, and then I AND it with that. So this way, if I do it with this, then I can just simply do oh. There we go. Fixed. Problem solved. I need to turn the bit. Like, now this is where I wish you could go back to assembly language. It's just easier to just do set bit. Accumulator A, 0, 1. like, come on. So, row equals row and this value. So first off, we'll take row equals 0. Clear it out. Row L equals, if it that, we don't want to AND, we want an exclusive OR. No, that'll work. We can do that, right? I have a feeling I just fucked this all up. All right, first of all, we are not doing anything with row low. We're going to get rid of the high. We're going to work on one row at a time. So we will do 1. Q. Oh, I got what I'm doing. I know what I'm doing. All right. If Rolo and Nat set that high, this one, we set this one high. We do next one. Meanwhile, I have my glasses off and the screen is all blurry. That camera's not even hooked up, man. It's just it's pointing at the floor. It's not going at anything. Here, we can go back to me. Hi. All right. So what I'm doing is I basically scrapped the code I had before, and now I will take a row value. So row value of 1 is going to only turn this bit on. 2 will turn this bit on. 3, 4, 5. So this will turn all these bits on. After all the bits are turned on, then I will latch it. So I should be able to go through 1 through 255, and it should work right. Well, so how this worked is what we learned last time is this only has, yeah, it's, what's blurry? What are you staring at? I can't make the font any bigger. Hold on. View font. Increase font size. Hey, look. The Arduino ID just locked up. Fucking piece of shit. I am not retyping all this fucking shit. Fuck me. Oh, there it goes. All right, let me save this file. It's like running really. What? Who wrote this shit? It's like a fresh install. Look at it. It's like, what is it doing? Please hold while the Arduino IDE responds. What the fuck is this shit? It's a fresh install too. Save changes, yes. All right. Can you see it better now? My apologies for the horrible font size. All right. So from last week when we did this crazy thing with the logic analyzer and everything, we learned that the columns, when the column output is pulled high, that whole column is turned on. There's no latching the columns, which blows total donkey. The rows are multiplexed. So the top 8 bits of the display. So this, imagine this is the display right here. This red area is the display. That's display. The top 8 bits is multiplexed with the bottom. So first you have to set these, and then you have to latch it, and then you have to set the next 8 right here. That's these. But you only do these ones. So first you load this in, latch it. Then you load these ones in, you latch it, and then you show the whole column. Wait for persistence of vision. Then you load this 8, then this 8, then show the column, enable persistence of vision. So you want to keep it on for so many milliseconds. And then you go to the next one, and then the next one, and then the next one. And then, so this is how this, so there's no utility out there to draw a font using that method. So I envision the font table looking like this. We're going to have like a number like 0 through 255, and then 0 through 255 for the first column, and then 0 through 255, 0-250. So this would be column A top. Again, sorry, my font is so freaking small. Let's make this bigger for blind people. So it would be column 0 top, like that. Column 0 bottom. Then column 1. Column 1. So in the end, we would have 1, 2, 3, 8. We'd have 16 digits to represent one font. Well, I mean, whoever wrote it, the controller that they wrote the controller, they had to build all this as well. I mean, it wasn't some off-the-shelf programming language. I mean, this isn't just, it's the designer designed it, and this is how they designed it. Go figure. So I am now, first I reversed the protocol. We got the protocol down. We need to figure out how we load it. Now this may not be the most elegant method of writing this. But it would help if I actually wrote it right. So if we did this right, so if I wrote a 1 to this column L value, it should only give us the 1. All right. So now let's try 255, and it should write up all 8 bits of the first half. So we'll go back to the overhead cam. All right. So it is writing 8 bits, but it's writing 8 bits for both the high and the low, which isn't, oh, it shouldn't. What I do need to do before I go into here is I gotta clear the pins. So for I equals 0 init, oops, switch views back here, guys. So we're gonna clear everything. We gotta clear these bits out. So clear I equals 0. I is less than 8. I plus plus. And then we're just going to do a digital write. Row pin 0. Row pin that. And this will just latch them all low. Done. Plain and simple. Or not. Let's do this. Let's go back to 1 on this one. Let's clear out both with the high and low order bits. Just do a blanking post to clear everything out. So I'm just going to basically I set all the bits low to turn everything off for the row. And then I'm basically going to pull both latches, and then draw whatever. So upload that. All right, there we go. We have 1. So let's try a 2. And this should be, so we're going to AND this out. So we should get both upper bits. Upper lights should come on. Only got 1. Well, that's because I don't know my binary. 3 is what we want to do both. Upload. 3. All right. So 15 should be 4. 255 should be 8. Am I counting 8 there? Yes. So now what I can do is copy this block of code. So now that I got this, the proper output of value, so I'm just going to copy this whole thing and just going to make a new function called void row L byte row L, or I'm just do byte row, and then I'm going to take this whole function, paste this in here, and take that out. And then I can copy this whole thing again. And call it row high. But this time we are going to latch 53. And then we can take this function that I wrote, and we'll call it void row C, which is a clear. So this function will clear both upper and lower latches. This one will load the low, which is the upper. This will load the higher, which is the low. So now we can take 2 values of row low of 0, row high of 0, and then we can just call our 2 functions. Row low, row high, row high. We also want to call our row C. Get rid of all that. What? What? I think I already got rid of it. Verify and compile. Happy. Upload. So this should have nothing on the screen? Correct. Now, let's try 255 here, which should bring... All right, so goofed up somewhere. Where did I goof up? This should be the last bit. All right, something's not right. All right, this is definitely working. So I just wrote this to it. So let's do 255 row. I think I know what the problem is. I think I'm going too fast. I might have to put a little bit of delay in here. We're gonna find out in a second. All right, that's right. Now 255. Upload that. Should only be the top half. This is the whole thing. So what we're gonna do is we're gonna do a delay. Just add one little delay in there. And we're gonna do the same thing right here. That didn't fix it. All right, what's going on here? Oh, I know what it is. I know what it is. I need to reset the row again. So I have a row C, but what I'm going to do is I'm going to do just a reset and not call the latch. And I'm going to call row reset. Right here. So basically what I'm doing here is I'm basically setting, instead of putting it in a variable and setting the variable, I'm basically resetting the port bits. So now I reset the row. So first I clear all the outputs, to clear the latch down, turn everything off. Don't need this delay anymore. Don't need that. Now, yep, exactly. All right, there we go. So let's do everyone's favorite bit pattern. One of 10101010. And that is 170. So 170 and 170 should give us alternating all the way down. So what we could do is we could take this. So that out. And now what we're going to do is we're going to start changing the value for each row. All right, let's just put this column value in here. It's going to look weird, but so what I'm doing now, so what I did was I moved the actual, so this is going for each column. So this will loop for each column. And then for each column, just setting, currently I just set the row and height. So if you imagine a byte array that has a font, so we're going to do a font array of, we'll just say the letter A. Don't know what the values are going to be yet, but we can just do this. A, and it's going to be a, we can just do this, A low. This is a horrible font table. And this is not really the font, but we're just going to just randomly put values in here because I can. So we can do 167, 32, 64, 11, 1, 2, 3, 4. All right, so we'll just say that as our font data. That's for the low bit. And this is for the high bit. And we will just randomly put some other numbers in here. All right. So we'll just say that's our font, our low or our high. So then what we can do here is we can just do A, L, C, and then A, L, H. Oops, nope, C. Nope, nope, H. All right. So now, as it goes through each column, it'll put 1 and 75, 67, 56. So it'll load these values in. Or I could just totally screw it up and break it. It's complaining that digit 9 is an octal constant. 1, 2, 3, 4, 1, 2, 3, 4. What do you mean octal constant? Really? Compiler fail. So this should look randomly like garbage, but as you can see, so now we just need to make a font table. Yeah, so we could do, so now we just need to make a font table. So let's try the letter A, which I got right here. So the first column, we want keep in mind this is the low order bit. So it would be 0, 0, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Like that, right? Delete that. Delete that. I don't, why do I have an extra row here? All right, there we go. 1, 2, 3, 4. 1, 2, 3, 4. So we know what this one is. That's 255. And the top one is going to be... Quick, what's the math? What's the math, boys? 1, 2, 3, 4. 1, 2, 3, 0. 254. So that should be our first column. That's this column. So we did that one. Let's change that to yellow. All right. Next column is, did I do that right? 1, 2, 3, 4. Okay. I think I goofed that up. That should be 4. So it's 1, 2. 1, 2, 3, 4. 1, 2. 0, 0. That should be not whatever the fuck I'm typing. Binary. 1, 1, 1, 1. 1, 1, 0, 0. 252. Column 1. Next column is going to be 3 on the bottom. And the cool thing is 3, 3, 3. Actually, no, 255. Then we did 3, 3, 3, 3. And then 255. Oh, code view. All right. Yep, there we go. Sorry about that. I need to get the command set up so you can change it. I have it set up. I just haven't started with it yet, where you can just type exclamation point cam 1 or cam 2 and it'll switch to view or something. That's another day. I want to do some Python coding for Streamlabs. A lot of people are asking how to do Streamlabs chatbot. So 1, 2, 3. I get 4 columns of 3. 1, 2, 3, 4, 3, and it's 255, 255, and then it's 67. So the next column is 254, and then it goes a 3, a 3, and then we're going 7. Then we're going back to 254. And then, so the last column is the same as the first column, 252. This column should be the same as the second column, 254. This column here is 7. Just 2 3s and a 7. So this should be the letter A. Survey says, all right, how about I speed it up? So we'll go back over here, change our persistence of vision up. And ta-da! We have the letter A. Yeah, unfortunately, I'm running 60 frames a second. So, I could do this. This might even get rid of it even better. So let me try that. Yeah, that's too fast. So, yeah, that's too fast. Put the delay back in there. You just do like 5. Blah! Sorry for the epileptic seizures. There, that works. So there's the letter A. And there's the code. So next we'll be figuring out how to make all these letters. The good thing is we don't need that many letters, but yeah, you got to function each letter. There's no easy way to not do this. But before you do that, is, and by the way, looking at it from this view overhead, I do not have a blinky. The blink doesn't exist. What I need to do. So the bigger problem is when I start stacking the modules, it may become an issue. Because drawing this one, I can go back to drawing this side, but as soon as I add another one, it's got to draw these ones before it can draw these. So it's got to go through the whole thing. Or I could just put a Arduino. Well, hold on. So if I draw this one, and then I switch to this one here, I go to do the next one. That's upside down. Oh, I had it right. So if I update this one to this one, so I'm basically doubling the number of columns. So as I scan through here, the persistence of vision on this one is going to start to get dim. So it might be just easier to take an Arduino and actually just dedicate a small Arduino to each one of these, and then just run I2C between each display and just have an address. That would be really easy for me to put a small Arduino on the back of this and then just have it on just one little chip, one little PCB. And then each one of these just have an I2C address. And then I just write, yeah, exactly. And then just say, display 5, show letter A or show letter B. And then they all have the same code. Then they all would have the same code and then go from there. The cool thing is I also have a panel with, I also have a ton of these modules. I have about 70 of these modules all tied together. But the cool thing is these are latchable. So you technically could load all the data up and all the displays, and then you just hit one button and then it displays it. And then you would load all the next data up, hit a button, and then it'll display it. This is these have latching columns and rows. So you basically latch all your columns and rows like a typical display, and then you tell it to load the whole thing. Which is why I don't like this configuration on this panel is the panel has, you can latch the rows, which is great, which is you latch them, but you can't latch the columns. So you have to update the row, latch the column, move to the next row, but you have to clear the row. And but this is a lot better than what I had. So I just got to create the font table, which shouldn't be that hard to do. It's just an 8x16 font table. So all you got to do is there's online font tables like this one here. I just got to figure out a way to, I could just easily probably write one in Visual Basic or .NET or something where I just type the letter and it just converts it to what I need to do and give me the values I need. I mean, it's not that hard to, I already figured it out. So, I mean, that's all I got to generate for each letter. Yeah, do it the old-fashioned way. All right, Brian, your job is to write a font table, and we want that to be in the free play Florida font format. Was that Times New Roman? I think all we need is letters 0 through 9 anyways. I don't think we need letters anyways for this. These are for the scoreboards for the Starcade. So all we need is 0 through 9. I don't think we need any letters at all. I mean, I could create the letters, but Yeah, this is not that hard. I mean, and technically I could have done this is I could have even made this a 2-byte array. So I could have done 8. I think it's like 2,8 like that. Multi-dimensional array. Here, I'll Google it. I haven't written a. Hello, Crocodile. How's it going tonight, sir? Multi-dimensional array. So it goes like this, which is weird. And then you do. So I can make that. Well, I didn't totally fart that up. All right. Anybody want to take any bets if I flipped it upside down? Let's see if I flipped it upside down. No, got it right. So yeah, so there we go. So I could just, that could be another way of representing these fonts like that. So that's the letter A. O is another. And then you could even go one step further. Yeah, I mean, literally, it's literally a flip flop. I mean, if you think about it, you're right. At the top and the bottom. Yep. So yeah, you could feel like O, like the letter O and 0. I mean, 1 is just. I mean, it's. We're not talking about a lot of characters here. Then we could. Why don't we just add some compression in here while we're at it? We'll just compress everything. Like. All right, so let's try the letter B. So the letter B is basically, we would do, let's put these back to, let's put X's back in here. So the letter B, center all this. So the letter B, we basically take this row, drop it on the bottom, this row, and drop it on the bottom. That's a horrible looking B. All right, so if we make that our B, that's an 8. There. Look, man, I'm not a graphic artist, all right? Don't be making fun of my letters. Talk to Proc. He's the graphic artist person. I'm the clicky mouse guy. All right. Yeah, this is where I really just need to write a quicker program in Visual Basic. I just click the little things off and drop. All right. Back to the fancy calculator system here. So we know this is 255. And this is 255. And then we're going to basically go 1, 1, 4 zeros, and then 1, 1. So that is going to be 195. And 195. And 195. 1, 2, 3. And then the next one's going to be 1, 1. Whoops. 1, 1, 1. 0, 0, 0. 1, 1. That's going to be 227. That's 255. Why is the bottom easier to draw than the top? What's up with that? And we got 0, 0, 1, 2, 3, 4, 0, 0. And that is going to be a 60. So there's the bottom. And the top is going to be pretty much the same as it was with A. Everything A. Everything's pretty much the same for the letter A, for the B. All right. So, and this needs to be called B. Let's see what B looks like. All right. Survey says there's a letter B. It's a horrible looking bee. But it's a bee. Fill in the top right. So make it like this. Like that. That better? It's a Venus. Oh, there's the letter B. So I guess the next trick will be to finish the font table. Oh, that one you don't like that one? You just really like this? You want like this? Like this? There. There you go. That better? Well, there's a so Alex, do you remember the program we used when I did the font stuff when we did that the font software I used to generate those fonts when we did I did those big LED matrix panels for that escape room? I don't remember what software I used to generate these font tables. Yeah, remember I just went into Inkscape or something and just drew the letter, and then it generated the font data for me. It was like super easy. I just click the letter and hit the button. I mean, it's not in the same format, but I can easily tweak it now that we got this. Like, this is super simple. I mean, and then what you do is I can just build a loop that just do a case statement if it's the letter A, but I can either do this is I could either add this to another matrix, do another array and make it a 27 by 2 by 8, depending on the letter. And then you could make one huge font table and then you would just index the font table by the ASCII value. So, but I just wanted to get, let me see if the GoPro looks any better with that. Yeah, so the GoPro doesn't have that as much spazzing. Still gets spazzing. So these are actually, so I have, so at an auction, Bill goes to auctions and he buys these stupid auction lots. So do you ever remember going to the DMV and you're in the DMV, you're sitting there and it says, now serving Q431 at window number 5. Well, these are the displays that say Q blah, 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 blah. So I ripped all these modules out of a larger panel. No, I don't think it was FontForge. I think it was like Inkscape or some GIMP or something. I think it might be in our GitHub. I'll have to check with GitHub, and I think it actually wrote it in there. I think it was either Inkscape. I don't remember what it was, but I think it's in there. You basically use a program, you draw the font, and then you save it as. Yeah, I think it's GIMP. So I installed GIMP, but I don't remember how I did it. But I think you draw the font in it, the letter, and then you save it as a C file, and you tell it what size it is, and it will then write the C file in the format. Yeah, so I think it is GIMP. I think it's what I used. So I just got to write the arrays and see if I can then convert those arrays to a format this can use. Because like I said, this delay module is wired in such a weird way. It doesn't conform to a regular array. So I also have these as well, Brian. I have these goofy modules, but the problem with these, yeah, they would be a lot easier to drive, but you would have to remove the processor, and then I just think it would be more, and then you only have digits. These are garbage. I'm not gonna do anything with them. I have 6 of these, and then I have a whole other panel in the garage with a whole other set. I'm pretty sure there's another. I don't remember how many I stripped from the space or at the space. I don't remember if it was 2 at the space or if there was 1 at the space. So yeah, I have those. I also have. Hold on a second. Entertain yourself. I'll be right back. Let me go crawl around the garage real fast. So, this is what I have. I have this module here. Let me switch views. I have this module here. I have about 60 of these. And these are 1, 2, 3, 4, 5, 6, 7, 8, 9 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 9 by 24. It says now serving. Again, I'd reached out to the company that makes this. I'm like, hey, I would like to use these displays I have for something. And they're like, not very helpful. They didn't respond. And they're like, that's just discontinued. You need to buy our new stuff. Like, well, if it's discontinued, how about you give us the information on the old stuff? That's not how it works. And then I have the even older version, which I think is the same. 1, 2, 3, 4, 5, 6, 7, 8. So these are 5 8x5 modules. I have about 50 of these. So I simply bought them for the... No, I have no plans for them. The only plans I have for them is throwing them away eventually because I'm tired of looking at them. So this is why I'm doing this. I want to build stuff with them. Not sure what. Yeah, so these are actually, this section actually comes off. So first of all, somehow it comes apart. Like that. Because they actually can be hooked together. So they get hooked together and you can daisy chain them. So this can unlock down here and then you can actually stack them. I haven't taken one of these ones apart yet. I don't know what's inside one of these. But I believe when I reverse engineered the other one, I'm pretty sure it uses the same kind of column and row matrix goofiness. And it may just be easier to use 2 or 3. Let me just open one of these up here and see what we got inside here. Let me switch cameras and we'll take this apart on the camera. We can learn together. Of course, I'm not going to really hear you guys, but I will. I'm thinking it's going to be the same. I think it's going to be the same, basically the same thing. Good thing is I have so many of these, I don't care if I break it. I mean, I literally bought, there's 27-gallon totes in the truck. I mean, the Trailblazer. I had loaded the whole entire Trailblazer up with this. There's, I think, you take one of those big 27-gallon totes, and it's completely packed full of these. I think there's at least 60 or 70 of them in there. I literally paid, I think, like a couple of dollars for all of it. Maybe $20, I think, is what I paid for all of it. Nobody wanted it. now serving piece is off. So we're now serving you. So the thing is we have to keep the red in front of the LED. So, but the cool thing is they have these RG45 connectors, RG11s, in. Oh, look at that. Slide that right off. With our red filter. Look at that. Those are big jumbo. Alright. Now these are individually addressed keys. Alright. There's our module. So we have power supply section. So up. Need to go up. Alright. Get this guy out of the way. There a few. There we go. So we have an in and out. Same as the other modules that we part. Apparently there's RAM. We have 250K RAM right here. Looks like RAM. IS. So I'll look that up. If that's a ROM, I may sacrifice a board to pull this chip off and read it, because this is an 87. I'll look this chip up. See if this chip is got internal code or external code. If you read the code off the chip, then we can figure out the serial protocol for this, and then we don't. It's most likely RS-45. They're all on a bus, and you probably have to set up. Probably press this button when you first turn it on. Set up address mode. So quickly, just looking at this, we have the CPU, which is an NXP P87C58X2FA. This is a power supply section. That's a fuse. These are resistors. Caps. The voltage regulator. Now, the cool thing is here, I can quickly see how this works. We have these transistors here are all drawing each row. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, which coincides with the 24 columns. We have 3 4094 chips here, which most likely are 8 bits each, so they're probably serial driven. Probably a clock signal, a data bus that drives these, so that would be 8 plus 8 plus 8, which is 24. So that's serial latch. And then we have up here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, which coincides with these 1, 2, 3, 4, 5, 6, 7, 8, 9. So all of these, this whole row is one big row. So this is a more traditional board driven. You basically serial load it and then turn the column on serial load it, turn the column on. So most of those tools that are online that generate the font tables work really well with this display. Being serial driven means you can drive it probably a little bit faster, and then your persistence of vision is going this way, up or down, which is easier. So we're only having to do 8 going this way. So envision this with this other display. So the other displays are drawing these displays in this order, like this. So we're data loading these over an 8-bit bus, and then we're showing this based on an 8-bit bus. This is basically, if you were to take this parent, it's basically this. The cool thing is we're not going this way, so we serial load this data, show it, serial load this data, show it, serial load this data, show it, and then we're just going down in a traditional horizontal, like a regular typical like a television or a CRT monitor. This is not traditional, very confusing. This, on the other hand, is super easy. The cool thing is so we have. It looks like what they did was this design was they used this chip as a frame buffer. If it's not serial, if it's an EEPROM, it could have a font table in it. But either way, we could remove this chip, figure out what our bus latches are. So we have again 24094s right here, maybe driving all this electronics. And this chip here might be driving all that. So then we only have to talk to one chip. This has got a ton of rows going into this. And all this goes into here. So they're using this to buffer between here and here. But it would be weird to buffer because it's only they're not like they're bicolor LEDs. However, the interesting thing is if you look at the board, it looks like the board did support 2 LEDs. There's actually 2 extra spots. Yes. So apparently they did make this as a bicolor module because there's extra sets of pads you can see they're missing. That is for a whole other set of LEDs. That would have been really fun. That would explain why they have the RAM chip with all the columns. That would be really fun. You got to latch both colors and then construct the column on. Cool thing is these LED modules aren't really LED modules. They are actually LEDs on the PCB. And it just has the bezel. And the bezel is actually in really good shape. So maybe maybe next week we will try to reverse engineer this one. Look up this chip. So I'm pretty sure this chip has been programmed to the factory. It is probably not able to be read. It has been laser etched with the name of the company and the firmware version. It says Humatic. We could try to reverse engineer the power supply, which we're still going to probably have to do. But I do have the I have the plug module that this plugs into and gives you a serial port. But then again, we still got to figure out what the serial data is. We could randomly just slam a bunch of values at it and hope something comes up with the display. But billion. So, and then we'd only need 2 of these for a 6-digit display. The font table would be easier because it's more of a traditional 8 by 8. They're actually square. Yeah, 8 by 8 modules. So that's 3 digits. 6 digits out of that. These are a little bit bigger, but these would probably be easier. So that's what we got going on. Can't hear me. So the whole time I was talking, no one heard me. That sucks. All right, let me just try this here. Can you hear me now? All right. Let me do this all over again. So, CPU, RAM, these are the row drivers or column drivers right along this line here. Hopefully you can still hear me. I will look back and see what happens. Looks like you can still hear me. So these are the column drivers. These column drivers are driven by three 4094 8-bit serial chips. The display does support two colors, but there's only one set of colors. The second color transistors aren't loaded. The second 4094 drivers aren't loaded. Each row is driven by one of these transistors. These look to be driven by, again, 4094s. This is the power supply section. CPU, static RAM, buffer for the CPU and the static RAM. I don't know what else is going on in here. Put on my blinders. All right, we have a serial EEPROM chip right here, 24C02. I'm pretty sure this is not an EEPROM. It's definitely static RAM. 256K is static RAM, which sucks. It means the code is most likely inside this chip, which pretty much means we're not going to be able to read it. It is probably burned at the factory. We have an on semiconductor up here. There's some kind of regulator right here. Buck boost transformer. These two transistors are the same, 64OTGs. 7805. So here we go. We have a 7805 regulator. So this most likely takes a higher voltage and then down converts it. And then it's a daisy chained as well. So it probably runs on like a 24 volt loop because these all get daisy chained. Obviously, there's a serial EEPROM here to control the address of the display. Each display is addressed. So it'll most likely be easier to remove the CPU, figure out which pins go to which chips, and then just wire that directly into an Arduino. Maybe use the same power circuit. You can figure out the power circuit. Looks pretty complicated power circuit, which doesn't make any sense to me, but they wouldn't want to run 5 volts on this. That would just be too much current if you had like 50 of these displays on a line. Button probably used for programming. Again, like I said, I looked online. I've tried contacting Qmatic. They don't want to share any information on the protocol. Actually, they didn't even want to respond to an email. I don't know. I mean, it's got an input and output port on it. I mean, but I could easily Yeah, I mean, there's no serial driver on here. There's literally no. It talks right to the CPU. Let's see if we can find some info on this CPU. P87 C58 X2FA. It is an ADC 51 8-bit microcontroller, OTP ROM. So this is the 87 C58 X2 P87 C58 X2. So it has 32K of OTP, no flash. It does have a serial port, 32 I/O ports. I don't think we can read the EEPROM out of it. Port 1, port 2, port 3. Here's our serial ports. Does support an external data memory. So you can tell it to run code from an external device. So maybe we can get lucky and this is actually not static RAM. That would be hilarious if this is not static RAM. Yeah, I don't know. Low cost version. It is Hillsborough County. So it is static RAM. So there's going to be no code in that. That's a stinker. Let's try this. Let's see if we can do. Let's see if we can just Google how to read OTP NXP 87 C 58. Is it possible to read the values of all the OTP registers once it has been programmed? How about we do verify OTP ROM? Yeah, I don't think there's gonna be any easy way to try to read this. So 80 P80 so part number P87 7 means OTP. Darn. 5 means has ROM. And 8 means it has 256 bytes of RAM and 32 kilobits of ROM. X2 equals 6 clock mode. So it runs at 5 volts at 30 megahertz. That's a fast little processor. It's got an ADC51 in it. All the address pins and data pins are brought out to the outside case. Program pulse input. Let me just bigger for you blind people. ALE program, address latch enable, program pulse, output pulse is latching the low byte of the address during access to external memory. In normal operation, ALE is emitted to constant rate of 1/16 of the clock, or 1/3 in 6 clock mode, the oscillator frequency, and can be used for external timing and clocking. Note that one ALE pulse is skipped during each access of external data memory. Right. Programming store enable, this strobe external program memory. So we could theoretically replace the static RAM with a ROM chip and tell it to run from ROM. Reset. Does look like the chip is still available. So we could just buy them and reprogram with our own code. Capture mode. All right. Baud rate. So it does have an oscillator on it. Downfall is the baud rate is internal. So it's defined by RCAP 2H and RCAP LH, which basically means it's programmed internally. We could look at the data coming off of it when it turns on. Maybe it will output something in some kind of format. Most likely it will probably communicate in the same format as it would expect to be communicated to. If it outputs anything on boot. So what I'm looking for here is the information on programming the OTP. A lot of logic about the UART. Boy, they really go in detail on the UART. UART framing error detection, input priority structure, interrupt registers, interrupt priority high register. All right. Page down doesn't work. Bunch of parameters. External data memory. I remember somewhere reading where someone wrote an external program that you basically it would boot the external program and then it still had access to the internal EEPROM. It's kind of the basically stuck it in a verify mode and they would just dump the RAM, dump the EEPROM contents out. Okay, when submitting ROM code to the ADC, the following must be specified: the 30K user ROM data, the 64K. All right, this kind of defeats it. Really? ROM encryption key. ROM security bits. Oh Jesus! Why has it got a security? What is this? Why would you need to think? Maybe it's not enabled. Security bit 2. When programmed, this bit inhibits verify user ROM. So this kind of means that we can verify user ROM? Ugh. Hey, let's make things better, Phillips. It's only a 19-year-old chip. All right, let's see here. My device list. Google Drive. All right, man. Have a good night. All right, let's see if this is on here. P89. P87 on here. P 87. C. 5. 8. All right. Question is, do I have the 39 base 0201? I have the 39 base 01. And I will need the 44 pin PLC adapter. 44 pin PLC adapter. So this little baby, and this little guy here, like that. I put the chip inside here. Put this in my fancy programmer, and I can attempt to read it. So, but that will be for another day. Keep that in there. And then I have the spare copper pad if I ever need it. All right. So I will remove the chip and see if I can read it. Don't think it's going to happen, but I'm not doing that tonight. I will most likely destroy the board doing it. But we can see. But with that, let's see who is currently on the Twitchosphere. Not sure how many viewers I got left. What do we got going on over here? 3 people. All right. Who's still online? All right. All right. We're rating the Donut King. Let's go watch some donuts. It's the Donut King. All right, fine. It's only one of you. Bunch of you there. None of you are viewing. Try to rate again. 1 viewer. I'm not rating with 1 viewer. 2 viewers. Yes, let's go check out the Donut King. Let's go. Off to go see the Donut King.
Raises a lot of money for kids. Almost 100 G's for children, isn't it? Or more. Dude, the amount of money that food and drink streamers raise for charities